It's probably going to be a little bit more of a quiet, low-key stream, sort of an odd day, work day for a lot of people still. I guess the Europeans, actually, even then, it's a little early maybe, but I leave for Sweden tomorrow, and this is like the only window where I could sort of cram something in here. So that's what we're going to do. So for those of you who haven't followed the project, Project SpaceCube is a game where you can build a spaceship out of cubes and add bits and pieces to it. Like I could go and, throw on some extra cubes and things over here if I wanted to do something like that, make the spaceship look even more interesting. And I can set mode into flight, and then if we do that, then I can fly with the spaceship. Right? It's like proper sort of space physics. If I start looping, then it'll keep on. That looks really cool, by the way. Look at that! Woo! We're leaving a helix behind. All right, stop the rotation. Turn a little this way. See if we can't just sort of halt our motion in general relative to the space dust, which was the most recent thing that we did add in there. For some reason, I don't know if it's because of the way that I've got the camera in here, but if I start a rotation after I've moved, it's a little bit wonkly there. But anyway, there's a spaceship. All right, excellent, wonderful. So what we're going to do today is we're probably going to be wrapping up the project. I said, so we got to the point where we could build stuff. And then I said, well, we want probably some sort of context for what we're doing. So I'm thinking an obstacle course. I can see that one cool thing to add in the future would be the ability to add like little laser guns or something to your ship. And then actually, like, while you're flying around, maybe have some things to blow up, right? You're flying around here, we go with the mouse and you click here, and wherever you click, that's where the laser beams happen to focus. That might be kind of a cool project, perhaps left as an exercise to the viewer. Because after today, again, I'm going to be gone for several days to Sweden. After that, I come back, and we're right into freaking Ludum Dare weekend. So the week before and the week after Ludum Dare tends to be dedicated to some videos dealing with some of those topics and things like that. So that's pretty much going to be the first half of December there. Of course, the last half of December is all like holidays, Christmas, New Year's, and I'm going to be back in Europe for 2 weeks. I'm going to be in Scotland for 2 weeks at the end of December, start of January. So the schedule is going to be weird and wonky and off. It'll be very clumpy. I'll still average, that sort of 2 videos per week kind of thing, but they'll most likely be in clumps. A couple of weeks without any videos and like, bam, 6 videos in 1 week. Something like that. Plus, we've got a new project. Looks like it will be around the corner, so stay tuned for actually a very exciting announcement over there. So, let's talk about our obstacle course. By the way, how did I get this spaceship to be here in edit mode? So what I did here is I started off with the normal. Let me disable you and re-enable you. This is the normal cube that we'd normally start with to build, right? So you go, and what I did is I did a bunch of changes to it. I added the cubes, I added the, the thruster, that sort of thing. I got to the point where it was happy. Now, of course, if I just stop running the program at this point, this goes away, the scene resets. But you can do something very interesting. This is a very useful trick. If you make changes to your scene in play mode and you want to keep them even when you go back to edit mode, what you do is find your object. Like in this case, it's the ship root object over here. Okay, get that and copy it. You can do Control-C or you can right-click and choose copy. You copy it, then when you hit the play button to stop the thing, right, we go back to our default scene. Well, I can paste that thing that I've copied, and therefore you get to keep a copy of it around. So what I've done is I went and designed that, boom, 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 this ship here, so we could do some testing without having to rebuild the ship every time to, get our parts the way that we want. I just built it, copied, paste. I think one other little change here is not here. Oh, in this script over here, I made sure to point this mouse manager script to the new ship root, this copy of the ship root, which affects just the camera locking on and stuff like that. But I think that's also why there's a little bit of wonky camera thing. So a little bit of a, just sort of a little bit of a hack to get it working with an existing design, but very convenient. So we're going to go with that, and we're going to test that. Visit me while in Sweden. Well, I mean, in theory, you could visit me. I'm going to Sweden for the Paradox fan gathering. They're flying me in over there, along with A Kiss for Luck, who you guys should hopefully know very well. And Marbazir is going to be there. Oh, God, I keep forgetting the name of the fourth guy. But, YouTubers and streamers. And we're going to be chilling out. It was an event that Paradox was selling tickets to so that, gamers could come and play video games with Paradox people and with us. And, we're going to party all night long doing that kind of jazz. Not being paid for this, but they are paying for the trip. We'll have a good time. It'll be fine. So, in theory, I don't know if the tickets are sold out or not, but, maybe you can come and hang out with me there. Okay. Bum, 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 bum. 3 or 4. Yeah, there's a Ludum Dare every 4 months, so there's 3 Ludum Dares a year. I think that's correct. Yeah. It's like April, August, December, something like that. All right, so let's get started. It's not the fourth guy, Bravstone. I think it's a German guy. That's why I never remember, because he's not like an English language YouTuber, so he never sticks in my head, which is unfortunate, but that's the way it goes. The Prime tickets were sold out a few days ago. That's too bad. But I think there's like 2 sort of sub events. Anyway, we'll see how it goes. All right, so obstacle course. What I want to do for this is I want to start off first. I think we need waypoints, right? I think especially in a space game where you can fly in any direction. It's not like we're going to constrain someone to a maze or, city streets or anything like that. It's wide open space. So I think we need to set up a waypoint system to force the player to go here, then there, then there, then there, then there. Okay? Standard thing. Maybe we'll make it look like, I don't know, a giant ring in space. That seems pretty reasonable, doesn't it, right? A giant ring, you're supposed to fly inside the ring. Boom, there's your checkpoint. You have one lit at any given time. Something like that. I think that sounds pretty reasonable. I also think we can probably just slap one of these together using some primitives inside of Unity to save ourselves a little bit of modeling. Although, in theory, you want to do that. So let's say we've got an empty game object here. We're going to call checkpoint. Checkpoint sounds pretty good. Just for the sake of whatever, I'm going to first center it. Then what I'm going to do is I'm going to grab it and just shove it off to the side here so that we can work with it. All right, so there's our waypoint here, our checkpoint here. It's currently an empty game object. Inside of that, we're going to have the graphics. And I'm actually going to create a sub-empty in here called graphics. And then in there, we're going to do... what I'm thinking of is, like, maybe start with a cube. So let's face straight on. We're going to assume we're going to be flying through this way. And we're going to offset the cube, probably make them smaller. I'm also going to remove the box collider from the cube itself. We don't care about colliding with the cube. This is just here for show. Oh, you know what we should probably do? Some sort of cool material. Like, I think it should be an unlit material. So it just glows in the dark no matter where you are. High visibility. I mean, unless we put blinking lights, do different things like that. Tell you what, we'll start very simple. We're going to create a new material. And we're going to call this matte checkpoint. Probably like an off and on, right? So there's one is active. So let's say matte checkpoint, and then we'll make another one of that, which is the active one. That's the checkpoint you have to hit. It'll be a brighter color. So what I'm thinking of is just a simple unlit color. That's it. It'll glow perfectly fine. We'll make it sort of a mid-sized, like sort of gray. Maybe a little on the darker side. This is still going to stand out very well from the pitch blackness of the background. Maybe not. I forgot that we don't have pure black as the background. So go something like this. Maybe, you know what? Maybe give it a little bit of a color. Maybe like a bit of a dim red. We'll see how this looks when we put it in the world. So our cube over here, we're going to give it the material checkpoint. Something like that. Like, yeah, it looks pink, but I think in the distance it'll sort of look like a dim red, desaturated red that's like... So we know there's a checkpoint over there, but it's not the active one. The active one should be green. All right, so we got the cube. It's smaller. We're going to offset it. We need to figure out, like, how much space in between of our checkpoint ring. Again, the outside edge is not going to be a hitbox. You can clip through the outside edge, not take any damage. So it's not like... Because if you build a really big ship... We don't want it to be so big where you get sort of stuck going through the checkpoint. That would feel silly. So it's just going to look a little bit like a ring. So I think maybe offset it by like... Let's say we offset it by 3 units. That gives us a radius of 3. Because if I take a cube, duplicate it, and put this one at, say, the -3 over here, that means effectively we get 6 units of space in between. Each one of our cubes on our ship is 1 unit. This ship is actually about 6-ish units wide. So this is going to be about the size of the ship. Well, seems fine to me. I don't know. I'm going to take these 2 cubes. I'm going to duplicate them. Then I'm going to go into rotate mode. There we go. With the pivot set to center. So now what I should be able to do is give these guys 90-degree rotation around the z-axis like that, centering around that pivot. Excellent. Then what I'm going to do is take them again, duplicate them, and then I'm going to rotate them 45 degrees. Oh, that's interesting. If I type it in, it's not doing the center thing. So I'll eyeball as close as possible to 45 degrees here and call that good enough. Then I'm going to take our first 2 cubes again, duplicate them again, and again rotate them. Just eyeball to where the inspector says 45 degrees, because apparently if I type it, it's just a local rotation. Good enough. Close enough for like Kerbal engineering purposes. So this is going to be the ring of our checkpoint. Seems fine to me. Seems totally okay. But it's worth noting again, I turned off all the hitboxes for all these things, right? So they're there for mostly for show. What we need now is a trigger, so that when our spaceship flies through this, we know. Now, we don't have to use a trigger. What we could do instead is we could have a piece of code on the checkpoint that just keeps checking to see the distance between itself and the spaceship. Right, and if the spaceship comes within, say, say 3 units of the center of this checkpoint, count that as a collision. You don't have to use triggers. You could have code that just looks for proximity and then bases things on that. But since our spaceship is going to be a rigid body with, a collider box and everything like that, it will definitely activate triggers. So, sure, why not, right? But if for some reason our spaceship didn't use the physics system, didn't use a rigid body, it might not set off triggers. I mean, you could still use a kinematic rigid body or whatever, but you might have a situation where your spaceship doesn't set off triggers, in which case you would just set up a sort of proximity sensor instead. But we're going to be fine. So what I'm going to do is inside my checkpoint object, I'm going to create another empty. And this is going to be called the trigger, okay? And we're going to add, I think, a sphere collider. Because I think we can, well, yeah, of course we can squish the sphere collider by messing with its size, right? So let's say our radius is going to be a radius of 3. There we go. So radius of 3 comes out there. That looks good, but from the side, it bulges out. And I don't think that's what we want. I think we want it to be a little flatter. So the nice thing about having the trigger on a separate object from the main, right? So there's the checkpoint object here, and if we were to scale the checkpoint object, it would mess up the look of all the objects inside. But what we can do is just scale the trigger itself to make it squishier. So we're going to scale it down in the Z, not the Z, not the Z. I thought if I scaled this object, the collider would scale as well. Apparently, the sphere collider doesn't work that way. That's interesting. I thought for sure I'd done this before, where the collider got swooshed in weird ways. Huh. I guess not. All right, we'll have to think about something. We'll have to think about something. We just got a tip in. Who'd that from? From Sir Linder. Hey! You and Ava are going to the Paradox event. Can't wait to meet you guys. Yes, Sir Linder! This will be, what, a 3rd, 4th meeting or something like that? It's going to be crazy. But yes, we will both be there. And we'll be participating in the overnight gaming thing. Don't know what we're going to be doing, but we'll see how it goes. So, I mean, I could leave that there. We could use a different type of collider as well. I'm really surprised that we can't scoosh this. But I guess that's fine. I mean, we could always just use, like, a plane with the renderer turned off and a mesh collider, and then that would work good. It might clip in weird ways. You know what? We're going to call this good enough. It's good enough. We can always do something else later on. I was hoping to, like, squish it, make it more of, like, a hockey puck kind of look. But we could always just draw something in Blender to use as a collision box later on. This is going to be fine. Okay, so it's going to have a trigger, and it should get set off whenever the spaceship goes through there. So that's going to be our checkpoint. Is it going to need a custom script? Probably, actually. Yeah, I suspect so. I don't know what it's going to do yet, but let's assume we're going to have a script called checkpoint, like this, which is going to, of course, be added. Just going to wait for it to compile here for Unity to start being responsive again. There it is. And then I can add it to the object. It's not going to do anything yet, but it's going to be okay. So I'm going to drop the checkpoint into the list of prefabs, and then I'm going to get rid of it from the scene. Well, you know what we could do? We could do a quick test to make sure that our stuff's working okay. So let's say we open this up like this. And we just want a void on trigger enter debug.log. We're going to say gameObject.name was triggered. Well, we need a plus over here. And I also need to embiggen our text. There we go, so you guys can see a little bit better. So, assuming I remember the name of this command successfully. And let's say we go and take... Why is it so slow? Oh, you know what? Probably doesn't help. The fact that I'm rendering video in terms of performance here. Let's say I take this object and move it to just in front. And then hit play. Hit set mode flight. Go forward. Oops. Well, I made one mistake. Our sphere is not set to a trigger. It was set to a collider. So we actually bumped into the sphere. Did you see that happen? Over here as I try to advance. Oops. Let's select this so we can see. Set mode flight. Boom. We just bounced off the sphere. And because that was a collision and not just passing into it, I don't think it triggered the trigger. So let's try that again here. Set mode flight. And we are not actually setting off the trigger. Why is that? Why, oh why, isn't the trigger triggering? Oh! I know why. Do you know why? I know why. The reason is because the checkpoint object here, it doesn't have the trigger on it. The trigger exists on a child. So for the sake of argument, let me take our script, our checkpoint script, let me add it to the actual object that has the collider. Let's hit play, flight mode, move forward. Now, trigger was triggered. It actually runs once for every collider, but that's okay. So why? So how do we get... We could leave the script on the trigger. That could work, but I would really prefer it if this checkpoint ran. I believe, and I'm not sure. Let's do a quick little test here. I think if I add a kinematic rigid body to the root checkpoint object, now it gets triggered. Bam. See that? So, we noticed this before with what? With what? Oh, when we were working out our, what code? Oh, in Mouse Manager. We dealt with this kind of issue in Mouse Manager, because I'd actually gotten an email about it. When you do a raycast and you try to find out what you've got hit, right? You do a raycast on an object for our mouse, for example, and raycast.physics, hitinfo.collider always returns the actual collider hit. Okay? Always returns the actual collider hit, no matter how deeply buried it is in the hierarchy. But you can also return hitinfo.transform. And this actually does two slightly different things. If there's no rigid body on the object, then it returns the transform of the actual game object with the actual collider that was hit. But if there is a rigid body at, say, like the root level of this object, if it has a rigid body, then hitinfo.transform does not return the transform of the object, of the collider that was hit, but instead returns the transform of the game object with the rigid body. Okay? Bit of a distinctive thing. And then there's also return hitinfo.rigidbody, which obviously always returns the rigid body on the root, or null, I suppose, if there isn't one. So hitbody.transform is a little bit wonky because it does slightly different things depending on whether or not there is there's a rigid body attached to the object. And something very similar happens with the on-trigger enter. Normally, if you don't have a rigid body, only the object with the trigger itself gets sent this event. But if you have a rigid body sort of higher up the hierarchy, you know, on the root object, then that object will get the on-trigger enter message. In fact, I think both would get it right now. I guess we could test that. So let's say I put this little checkpoint script back on trigger. So both trigger and checkpoint have the checkpoint script. And if we go and just move forward here a little bit, yeah, they both get it. See, trigger was triggered, checkpoint was triggered. Okay, but we don't want that. We only want the root one to be triggered, so we'll do that. We have a kinematic rigid body on there. Kinematic means it does not take in physics information. It never collides with anything. It doesn't have velocities. It doesn't do anything other than the fact that the kinematic rigid body is something that the physics system is a little bit more aware of. Also, if you don't have a rigid body, it's considered more of like a static collider, which leads to somewhat different optimization internally to into the PhysX system, where colliders that don't have rigid bodies on them are assumed that they never move. colliders like that are really good for your level geometry. And again, the physics system can do certain optimizations based on the assumption that this object never moves. Whereas if it has a rigid body on there set as kinetic, again, or kinematic, it doesn't intersect, it doesn't collide, it doesn't work with the physics system, but the physics system expects it that it'll probably move at some point. It's good things for things like platforms and whatever, and it uses a slightly different optimization. Basically, if you're moving static colliders around, generally bad things happen, so you want them to be kinematic rigid bodies if they're ever going to move. Now, our checkpoint's never really going to move, but it does need to get these little alerts. So we're going to do that. That way we can have our checkpoint script on the base object itself. That's great. We're going to apply the changes to our prefab, and that's all hunky-dory. Okay, so now we've got some sort of checkpoint available, which, okay, that's fine, but one checkpoint does not a map make. Now, of course, we could go and make a whole bunch of these, right? Boop, boop, there we go. Here's our obstacle course over here. But that sounds like a pain in the butt to place all these, especially since we're going to be working in 3D space, and then you end up with something that's always exactly the same, and that's maybe a little bit on the dull side, right? Wouldn't it be great if we could come up with a system to place these on its own? And that's entirely what we're going to do here. So what we're going to do is we're going to create a new empty called obstacle course. Sounds fine to me. I'm going to center it. Again, it's not critical that you do, but tends to help your organization a little bit. And we're going to want some sort of component for it called obstacle course. Okay, we're going to do that. And just wait for it to compile. There it goes. We're going to drag that onto here. And then we're going to open up our code. So our obstacle course is going to need to know something. First of all, it's going to need a public game object reference to the checkpoint prefab. Okay? Because it's going to be spawning these for us. That's what this is going to do. It's going to automatically spawn a series of checkpoints in an interesting manner. Well, ideally. So we need to say that, here you go, there's your checkpoint prefab. Awesome. And then we'll probably want something like public num checkpoints. You know, and if we can randomize it, we can do different things. But let's say we say, all right, we want a race course that's 10 checkpoints long. Okay? I guess I have to specify that this is an integer. We probably want to do something like I'm not going to make it float for now, and I'll tell you why in a second. Something like min distance. So this is the minimum distance between these prefabs. We'll say 20. I don't know. And float max distance, we'll say something like 40. The reason I'm not making them public right now, and I will want to do that, is because if you do, then it starts being, the values start to become managed by the inspector and with the serialization. And then if you change this number here, it doesn't change the inspector. So when I'm working early on, I like to do it this way. That way I can change these numbers and have them actually update. And then once I feel like I've found reasonable defaults, then I make them public, and then the serialization system handles it. Otherwise, you get some unexpected stuff. YK Sleep, thank you very much for the resub. We've got J-Baby with the resub as well. Am I feeling like we're not getting the alerts? I'm probably, you know what, I probably just have my volume set too low. That's probably exactly what's going on here. So I'm probably not hearing the alerts. My bad. We've got Hedzu, who just subscribed. Thank you very much. Hedzu. And Essie at 34 months, a little while ago. Essie, I still remember you from our Darkest Dungeon. And then Sarah Linder with the resub as well, 34 months. Nulani earlier with the Yay Programming. Excellent. Curious what prompts these dev streams. Did you just get a great idea? Oh, J-Baby, I have a second programming channel, youtube.com/Quill18creates, and that is supported by Patreon, patreon.com/Quill18creates, and one of the milestones on there is, for us to do programming live streams once a month. So, that's what happens there. In terms of the inspiration, I don't know, just kind of come up with stuff that, you know, makes sense within the scope of our project. But yeah, and I just heard a tip come in over here. And yeah, I did miss one earlier as well from Fishik. Thank you very much. I've been planning a vacation to Canada. My mom and I are dual citizens of USA plus Canada. Nice. Franco, Ontario. Hey. Even though I've never stepped foot in Canada, which landmarks would you recommend? Well, I mean, that really depends on where you're going. Turns out Canada's pretty big. I don't know if you're aware of this, but Canada's relatively large. So recommending landmarks is kind of on the difficult side. You know, Toronto's a lot of fun. And there's a lot of stuff to do there. So, maybe? I don't know. But if you're Franco-Ontarian, so there's that. But if you do speak French, you'd have a good time in Quebec as well. And we also got a tip in from Hi from Sweden, who says, hey, Quill, did you miss me? I have unfortunately missed your streams. Oh, well, that's too bad. Thank you very much for coming by today there. Hi from Sweden. Bum, 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 bum. All right, just trying to see if there's any questions that I should be addressing. Maybe again, as Circle Collider. Circle Collider is part of the 2D physics system, and the 2D system and the 3D system don't really interact. And by don't really interact, I think they literally don't interact, because the 3D system is handled by PhysX, and the 2D system is handled by the, what's that called? It's like an open source 2D collision system that is used by, like, it's been ported to everything from, you know, it's been around for ages, like Flash games and different things like this. Anyway, so a Circle Collider I don't believe would interact with any of our 3D colliders in any way. I'm not sure. As a physicist, I must ask, how profound will your physics going to be? Well, they're all just going to, it's all just Newtonian physics, right? The physics system is just Newtonian physics. No relativistic effects or quantum effects, unfortunately. We'd have to simulate those on our own. Box 2D, thank you very much. That's the name of it. I'm pretty sure Unity ported Box 2D. That's its 2D engine, I think. So anyway, anyway, the point is I don't believe they interact in any meaningful way. Okay, so obstacle course. We have number of checkpoints. We have the ability to have checkpoints. Clearly, what we're gonna want is some sort of spawn course command. Okay, which most likely we'll just simply call on start. I mean, we could just run the code in start, but it's often better to do this because, honestly, there's going to be lots of times when you might want to delay spawning the course, you may want to respawn the course and do different things like that. So we got that. I think what we're also going to need internally is probably a list. So we need system.collections.generic. I don't know why this isn't like the normal template. And what's annoying is you can modify the template that Unity uses to generate your classes like this, and so you can change it to always use .generic. You could also change it to say always include, say, unity.ui, which, I mean, isn't really a problem. You could change it to do all those things. The problem is every time Unity updates, it resets your templates, so you have to redo it, which is kind of a pain in the ass. Anyway, I don't know. Anyway, so we're gonna have some sort of list of checkpoints. I guess we're gonna call it checkpoints. And do this. Also, I should really get in the habit that my publics are going to have the capital letter over here. And again, this will actually be a public later on, so I'm going to go ahead and capitalize it. I'm just not capitalizing it now because I'm trying to avoid the serialization. I mean, I could make it a public and then put in the system.non-serialized. But again, later on I do want it serialized, so let's just do this. It's going to be fine. So we're going to have a list of checkpoints. So I guess what we're going to do is we'll also have some sort of, like, cleanup command, maybe, which is going to just delete old checkpoints, right? Something like that. So if checkpoints not equals null, and check, oh wait, if it's not equal to null, that's going to be fine. And then we'd do something like for each, I mean, then, yeah. For each loops, you do want to avoid for each loops in, like, something that's really frequently repeated every single frame, like many, many times, because it does add a little bit of overhead to get the iterator. If you just use a for loop, there's a little bit less overhead. But for something that doesn't run all the time, I really like to use for each loops because they're conceptually very clean. Oh, my head's in the way. Yep, let me move that. My bad. They're very clean, and I like the language of a for each loop. Right, seems nice. So for each checkpoint, CP in checkpoints. Oh no, I'm going to be modifying this. What are we doing? We're destroying the item, but we're not actually modifying the thing. No, this is going to be fine. So for each checkpoint, we're just going to call checkpoint.gameObject. Or we're going to call destroy cp.gameObject. That's going to be fine. So we call that. What this does is it actually just sets a flag. It doesn't instantly destroy the object. It sets a flag on this game object. At the end of the frame is when the object actually gets removed from the scene. So that's going to be that. We're going to loop through, set every game object to be destroyed. That's going to be fine. And then at the end of it, we're just going to go and say, all right, so our checkpoints, we're just going to go and clear out our list over here so that it'll get garbage collected at some point. Groovy. All right, so in spawn course, what we're going to be doing is we're going to say checkpoints is equal to a new list of checkpoints. That's good. And then we're going to say for int I equals 0, I is less than num checkpoints. So we're going to loop through 10 times. We're going to create a new checkpoint prefab. Yeah. Let me do this. So this is going to be the checkpoint game object. We're going to instantiate it from the checkpoint prefab. And again, as always in these tutorials, I'm going to be a little bit more verbose, do things across multiple lines, even though you could sort of group them up a little bit more, but that's going to be okay. So we're going to instantiate new copy from the prefab. Instantiate returns a generic object, so we're just going to make sure to explicitly cast it to game object over here. So we've got that. All right. Now, in our list, we actually have a list of checkpoint objects. We could change this to be a list of game objects, but I think I'm actually going to be quite happy to have the list point to the checkpoint component, which is fine. So we're going to say something like, well, tell you what, I will take this like that. And so this is, again, we're doing it very explicitly. We're going to get the component of type checkpoint from this game object. There we go. So we've got that. And then in our list, which is checkpoints, we're going to add a reference to this. So now we've got our list has got this new checkpoint. We're going to loop through this 10 times. Awesome. So that's the sort of like bookkeeping side of things. But now we need to position the checkpoint in an interesting manner. You know, and what does that mean? What does that mean? Well, to start off with, what I'm going to do is I'm going to create them all in a line. That's what I want to do first. So let's have some sort of vector 3D where we keep track of the sort of the last checkpoint position. So we're going to call it the checkpoint position, and we're going to have it default to the position of, say, our ship, right? Start wherever the ship is. That's going to be where we're starting this obstacle course. And we're not going to spawn a waypoint right there. We're going to spawn it some distance forward, okay, from that point. But let's assume we're going to start wherever the ship is now. We want to spawn a checkpoint, like, starting from that point of view, which is fine. How do we find our ship is an excellent question. Right now, we're mostly keeping references to the ship. And I guess that's going to be the way that it is. I don't like, So here's what I'm saying. What I could do over here is set a public game object called, what do I call it in the script? Ship root. Okay, public game object, ship root. Actually, I don't think it's even a game object. I suspect it's a, is it a transform? It might be a game object. Yeah, ship root. Okay, so we can do the same thing over here, and if we do that, so in our obstacle course, and we remember to save our changes, and we don't have a typo. Oh, hang on. Shiproot.transform.position. There we go. Compile, compile, compile. Good. Changes are there. Excellent. Let's make sure that our checkpoint prefab is dragged in there. And so then what we could do is we could reference the ship root. Now, that's probably fine because the ship root's probably not actually going to change very often. Right now, it's a little bit annoying because I have to remember to update it. The other thing we could do is we could look something up by name. We could actually have our obstacle course script go into our mouse manager script and just copy what it's there. We got a few different options. I suppose for now, we'll just drag it into the inspector and hope that's okay. So we'll do something like that. I mean, in a sense, it's almost not like ship root itself. Right? What if, instead of, like, we're not linking to ship root. What we're looking for is we want to link to the obstacle course start position object. Shut up. It's a perfectly fine name. Right? So that's the idea. And that's going to happen to point to, oh, now I've got an error. Shut up. It's a great name. It's fantastic. I don't know what you're talking about. There we go. So this has happened. It's going to point to this. Maybe at some point it's not going to be the ship that we're using as the course start. Doom. Done. All right. So we've got that in there. So the idea is we're going to use that. And what I'm going to do, for each one of these objects, we're going to set the position. Now, when we spawn the object, just to keep things clean in our hierarchy, I want to say that this new checkpoint game object, its transform, we want to set its parent to be this dot checkpoint.transform. We want the checkpoints to be a child of our obstacle course object. Keeps our game hierarchy neat and clean by having everything nested. Very nice to do. So we're going to do that. That's going to be great. So our position is going to be doing this. We're going to take the old position, and we're going to add, to start off with, we're just going to move forward. Forward is positive Z in our particular context. We're going to move forward by min distance. Like this. That's all we're going to do for now. We'll make it more interesting later on. But that's what's going to be the position. So then we're going to say the, the checkpoint game object.transform.position is going to be equal to this CP pause. And we're changing this so that every tick, we're going to go further forward. So now we should get them all nicely in a row. And it's position, not local position, which is the world stuff, which is good. Let's give this a try and see what happens. We got a compiler errors. What's we're getting? Oh, new vector 3. Excellent. So if I hit play, we should get an obstacle course. And we do! Look at that! Hey, hey! Now, how do we feel about the distances? To me, it seems like a distance of 20 is too small. And honestly, I think I want these rings to be bigger. Right? I think that's probably relatively reasonable. So let's go into our checkpoint here. And both the graphics and the trigger, we're going to scale them up. I'm going to set the radius of the trigger to be 6. And I'm just going to take the graphics and just double up on the size. Boom, boom, boom. Like that. So now if we hit play, there we go. I think that's a much better size for our rings. And then in our code, we're going to make the space a little bit more. I think maybe a minimum of 50. And we haven't played with the maximum, but let's try something like that and see how that feels. Okay, there we go. I think that's a relatively good minimum distance. We may even want it to be bigger than that, but yeah, that's going to be just fine. Right? Groovy? Excellent. All right, Disco Mole. I'm going to give you a slight warning here to just chill out. Just chill out. It's cool. Just be relaxed, because right now you're kind of a 9. We need you at a bit more of a 4. Make the distance speed dependent. Now that's interesting. There's something like that could happen. Right now, we're going to be okay with that. So what I want to do now is, before I start working on the curve and making it look more interesting, what I want to do is introduce the idea of having a active checkpoint, right? Which we don't have right now. Right now, they don't really do anything. The active ring should be larger than others. Maybe. Oh, the other thing the active ring could do is sort of pulse. Right? What I want to do first is colorize it. So we have our material for the checkpoint. I want to make a different material called mat checkpoint active. Like this. And I want this to be like bright, shiny green. Like that. Very, very, very visible. This is the active checkpoint. It's very similar to our snap point texture. In fact, it's basically exactly the same. But that's okay. So I want the concept of an active checkpoint to happen. So probably that's the obstacle course that's going to have to manage that. And I say that because the obstacle course is the thing that knows our list of checkpoints. So at some point, what we're going to need to do is something like, so if we kept, let's say we have something like checkpoint, active checkpoint, like this. You know, there's lots of different ways to organize this. Actually, you know what? Instead of having a reference directly, we could have this be a number. Just the index of the active checkpoint. Well, that's probably a lot better. Int, active checkpoint, index. Like this. Okay? This would default to 0 regardless, but we'll make it explicit that way. That's going to be fine. And again, in the spawn course, when we set up the list over here, we're going to make sure that the active checkpoint index gets reset to 0. Like that. So that it doesn't remember the old one. Okay. So what we're going to say then is something like, we're going to make a public function in here called something like checkpoint was triggered. Okay? It takes in a checkpoint like this. And the idea is when our checkpoint triggers, all it's going to do is refer back to the obstacle course. So let's say it's going to have in here, it's going to have a public reference to obstacle course. Yeah, obstacle course like this, which does feel awkward. That's fine. This doesn't have to be serialized. It doesn't actually make a difference, but let's just do this. And then what we're going to do is when we spawn our objects over here, we're going to make sure that cp.obstacleCourse points to this. So now the checkpoint has a reference to the obstacle course, and when it gets triggered, it's going to call obstacle course dot checkpoint was triggered this. So again, our checkpoints are going to do very, very, very little because the obstacle course is responsible for actually managing things. So the question is this the active checkpoint? Right? Because someone could run through one of the red rings and that would cause it to be triggered. I mean, we could toggle triggers on and off for the inactive ones if we wanted to. I guess that might be fine, but let's just go ahead and do something like that. So is this the active checkpoint? So what we're going to do is find this ID. This index is going to be, so in our checkpoints, we're going to get, what's it called? It's not find. It's, index of. There you go. Index of this object. We'll give it this. This is so not the optimized way necessarily to do it, but it's going to be perfectly fine. I mean, if you had a list that was going to be like 1,000 checkpoints, there's faster ways of doing these lookups, but this is going to be perfectly fine. So we're going to find the index of this, and we're going to say if this index not equals active checkpoint index, then we just return. This is not the active checkpoint. All right, we just return. So we do that. If it is, here's what we do. So we're going to have two extra little helper functions. Inactivate checkpoint. And another one that is void activate checkpoint. And the idea being, after we set up all the checkpoints over here, we spawn the course, we're going to activate the very first one. So from our list of checkpoints, active checkpoint, which is just the same as 0, we're going to make sure that one becomes active. Done. And what this is going to do is it's going to set up the colors and update various things. So over here, checkpoint was triggered. So if we get to here, then we've got the correct one. So what we're going to do is actually inactivate CP. We're going to turn off CP, and instead what we're going to do is we're going to set active checkpoint index ++, and then we're going to activate that one. We can just copy this piece of code over here, like that. Okay, so we inactivate the old one, we activate the new one, done. Although one thing to check is, whoops. Oh, there it is. That was weird, little display glitch. If active checkpoint index is greater than or equal to the number of checkpoints, then we have finished. So debug.log course is done, like this, and we'll just return because there's nothing to activate, but otherwise we do that. Good, groovy, excellent. Ba-da-da-da-da-da. Any good questions? Oh, yeah, we have to get it animating too. Well, we'll deal with that later. Maybe. I don't know if we have time. We'll see how it goes. We're looking for about an hour here. We're already 45 minutes in. We'll go over our allocated time. I'm 100% sure. So what we're going to do here is we're going to, what does an active checkpoint mean? We're just going to change the texture. Or change the material. That's all we're looking for right now. Yeah. So what we need really is we need two more publics. We need a public material that is checkpoint inactive. Maybe I'll call it mat checkpoint inactive, mat checkpoint active. Okay, a couple of references like that. And we're going to make sure to link those to our obstacle course. So that's inactive, and that's active over here, like that. So then all we need to do is say over here, we're going to get all the renderers on this object. So cp.transform.getComponents in children. We're going to get all of the mesh renderer components that belong to the checkpoint. And there are going to be more. There's one mesh renderer for every cube in our little ring there. So we're going to get them all. All right, this is not just direct children. We could include inactives. That we don't need to do. But yeah, that's going to be good. So we're going to get an array of mesh renderers that we're going to call MRSs. And then for each mesh renderer, MR in MRSs, what we're going to do is we're going to set, its material to be equal to the mat checkpoint active, like that. And then on the other side over here, we're going to do the same thing, but for inactive. Now, because there's so much code, the duplication here, this could probably be generalized to single function. On the other hand, we're only talking about 3 actual lines of code in here, so it's not a big deal. Any chance this works? I guess we'll find out. Can you fly with the ship yet? Yeah, absolutely. We've been able to fly with the ship for some time, actually. So I'm going to hit play, and in theory, the very first ring will be nice and bright and green, and it is. Boom, like that. And then if I set mode to flight, and I give us a little forward movement, when we go through the first ring, it should become inactive, and the next one becomes active! Vroom! 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 Look at that! Hey? Hey? Excellent stuff. Excellent stuff. Okay, that's exactly what we're looking for. So, next up is what? And first of all, I'm going to get rid of all the noise that's in here, because that's all these debugs don't have to exist. So next thing we're going to do is we're going to try to make the obstacle course a wee bit more interesting. Instead of having each checkpoint an equal amount forward, which is nice for testing, but not really the ideal way to go forward, we're going to try to make this a little bit more interesting. Here's what I figured, right? It's easy to imagine what we want the obstacle course to be is feel like a series of sort of twisting paths, right? Pretty legit. So what I'm thinking is this. Every time, instead of advancing the next checkpoint, say 20 units or, distance units forward, instead, we figure out distance unit forward, but then take that distance and rotate it a little bit, by some amount of degrees, say up to 15 degrees or 45 degrees, or we'll test with a few different numbers to this. And then each one will be a certain amount of degrees offset. So you end up doing these sort of like curves, never too sharp. The idea is ideally, and you can compare this, if you ever played like the races in, I don't know, Grand Theft Auto or something like that, or the Forza series or something, right? The Forza Horizon ones where you have to go checkpoints. The next checkpoint is always going to be sort of in front of you. Now, a lot of those were hand placed, but as in space here, where we don't have to worry about like buildings obstructing the view, as long as the object is never more than X number of degrees off to the side, then it's always going to be within vision range of your camera. So you'll always see the next checkpoint as you go through one of these, which to me sounds pretty good. So let's say with these this distance, we're going to have another float. I don't think we need a minimum for the angle, because sometimes, having it be straightforward is going to be perfectly fine. We just need something like a max angle. And let's start with something like 30 degrees. Just got to pick something to start off with and see how that feels. So what we're going to do is we're going to just change this slightly. We are going to say that we are going to have a vector 3 called offset, which we're going to start with some amount of distance. It's actually, what we're going to do is we're going to do random.range from min distance to max distance for the z component of this vector. And we're just going to offset the position by that. So that's good. But then what we're going to do is we're going to rotate it in some direction. How do we rotate by a random direction? I guess, because, there is random rotation. But we want to limit by a certain angle. So I think what we're actually going to do is something like quaternion dot Euler. We'll use that, and we'll rotate it randomly. We don't want to rotate it around the z-axis. We don't need a twist. That means nothing. But x and y, we're going to rotate it randomly from there. Sorry, I'm hesitating. I'm like, we have to remember what the last thing was. See, CP pause is the absolute position. But we kind of have to know the relative position from the last one. Actually, we don't really need to know the relative position from the previous object. But we do need to know what direction the last gate, the last checkpoint, what direction it was pointing in. And we want to rotate based on an offset from that. So we need, just locally over here, we need a quaternion last rotation, which is going to start at quaternion.identity. So we're offsetting that much. Yeah. Okay, so we're going to do something like this. You know what? To test, I'm going to just rotate 45 degrees on the x-axis. Actually, no. 45 degrees on the y-axis. Okay, so right now, every gate should be 45 degrees to the right from the last one. So that's that. We're going to add, so last rotation, so we don't add quaternions, right? You always multiply quaternions, I'm pretty sure. Surprised that's not going to be an error over here. Yeah, I was going to say, you don't add them together, you multiply. So whatever the last rotation is, we're going to rotate by 45 degrees on the y-axis. Excellent. And then what we're going to do is we're going to use this new rotation, multiply the offset, and that's where we're going to be changing our position from. So there's going to be that, but also the cp.gameObject.transform.rotation is going to be equal to this last rotation. So I don't like the fact that they're not, you know what, instead of last rot, we're going to call this cp rot. There we go. Let's try that and see how badly I effed up all the math. I'm gonna say pretty bad, actually. Let's minimize these rotations here. Oh, no, it's working. There we go. I just I underestimated how much 45 degrees would do. So this one, every single one of these, while the distance between them varies, they're all 10 degrees to the right from the last one. That's good. That's exactly what I want. Checkpoint 1 shouldn't get that you... I guess it depends. The question being, should checkpoint 1 always be directly ahead of you or not? I mean, I could make it so that the first checkpoint is always directly ahead. But, you know, the slight angle here is fine. So if we set mode to flight, already this is going to be damn tricky. Because you have to remember, first of all, I have to fix my camera rotation thing at some point, because there's something that ain't right with it. And I don't know why that is. It's fine here. It's like when I start moving, one of the things, I must do something globally instead of locally in the wrong place somewhere. Almost certainly, but that's okay. So we're going to fly through here. Bam. And the next one. Whoop, 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 whoop. This is hard. Excellent. Okay. Newtonian physics. Because now I'm drifting sideways, right? So it's like, oh, right. If I'm going to do that, I'm going to have to kind of counter, slide backwards into the thing. Excellent. Now I'm drifting off in a weird direction. If we did increase the drag on our ship, which again in space, well, there is drag actually, but not very much, then it would make this a little easier because it would sort of arrest your sliding a lot more. All right. I'm going to say 10 degrees of offset is pretty goddamn good. So let's change this up now. So first of all, the max angle, I'm actually going to change to 10 degrees. That's going to be fine. We may need more space between our things as well, but we'll see that. So now, max angle. So we're going to rotate around random dot range. So by rotating around the X, we'll end up with up or down motion. So we're going to go from negative max angle to positive max angle. And we're going to do the same thing in the Y direction. And again, we don't need the Z. If we did rotate around the Z, it would mean that our checkpoints would be just sort of tilted, which might make sense if your checkpoints were different. Imagine your checkpoints look a lot more like like checkpoints for like a downhill skiing, right? Like a slalom skier, where you've got a flat surface with a couple of flags. Well, you could use that for the spaceship, right? You still have to go through there, but imagine like that flat platform starts to turn. So now all of a sudden it's like, okay, it's really hard because you got to dodge the terrain. There's things like that we can do. So let's get you there. Let's get you there. Let's get you there. Just a little bit cleaner. That looks nice. And let's run this. So if we take a look, there we go. And you see, it almost looks like we're drawing a spline. And you could do it in a sense. You could do some sort of spline or something like that to determine this, but there we go. We're looking like a roller coaster that we've got to follow now, which is pretty good. Let me go ahead and maximize this view. I'm just going to pull back a little bit with the camera like this. Set mode to flight. Okay. And let's see if we can do this. Tilt down a bit. Oh man. I have to, one thing I have to add, because if you right click on, okay, there's definitely something off with our right click dragging code, which I've got to check. But if you right click on an engine, you can rebind the key for the engine. But I think it might be handy if in addition to doing that, you could change how much thrust each engine does. Like the forward thrust makes great sense, but this is very fast. You have to be so delicate with your up and down kind of thing. And remember, when I rotate here, I'm not actually changing my path in any real way. I don't have, I could do that. I could change it so that, because right now my engines are all mapped to just help me rotate, right? My left and right and up and down just help me rotate. But I could make it so that they instead all fire at the same time, therefore they would push me up and down. Oh my god, this is so hard! I love it. Okay, now, this way. No, stop. That way. Oh, god damn it. Luckily, we have a lot of angular drag, which stops the rotation, which again is not very realistic, but is sure as hell handy. Oh my god, this is so hard. I love it. We got ourselves a bit of a game here, you guys. And yeah, I could design this. Oh, for crying out loud. Just point that way. Now go. No. Oh my god, I'm going the wrong way. Forward. Yes. Oh god, I'm going so fast. No! Shit! Alright, we're lost in space. We gotta do a rescue mission from Kerbal. Yeah, we could make this a fair bit easier, because there's already some drag for... I didn't realize there's no regular drag. There's only angular drag. Really? Okay, that would explain some of the difficulty. Because now, if I do this, eventually I'll come to a stop. Right? Again, not realistic, but it sure makes your life a lot easier if your ship comes to a stop naturally. Adding drag also, because of the way that it gets calculated, also gives your ship a maximum speed. Yeah, I gotta like down tune the engines that are responsible for going up and down and twisting. Oh, this is so much easier now. It's still a challenge, but it is a lot easier because eventually your ship comes to rest. So then you can just sort of point yourself in the right direction and just thrust that way. Vroom. Whoop. Come on, you can do it. There you go. Yes. All right, we got this. So add some sound effects, make the rings look really cool. Again, we can build these ships. I can just go, change mode to edit. Shouldn't have kept moving. It's probably not correctly turning off the kinematic here because of the way I've got it pointing. But we can modify the ship at this point, right? I can say, oh, let's add a cube here. And yet, I think the camera's bound to the wrong object. There's something weird going on here because of the way that I've got it set up. And I still have my rotation screwed up, but that's okay. But yeah, like that, we got a freaking game. Ooh, make checkpoints that you pass turn gray. Oh, I like that. So let's create a new version of the checkpoint here called checkpoint passed. And yeah, just make it a very dull gray to distinguish things that are coming from things that have been. So we'll make another one called passed. And so instead, when we inactivate it, it's actually more of a past checkpoint. We really switch this to material past. Like this. That's a good idea. I like that. And then we need to make sure that our obstacle course has a reference to that new one. Oh, set mode flight. I'm like, why isn't the camera following? That's right. And then, yeah, one of my rotations is off on my camera. Set mode flight. There we are. So now, as we pass through this... There we go, it turns gray. Oh, I like that. Yes, very good. Good suggestion. Who was that? Stabilize material mechanism of sort. Well, there is. The drag actually stabilizes everything for you, which is good. The big problem right now is just that my thrust is so crazy big. When I just try to, like, one little tap of my sideways, like my up and down, like, I'm ending up going almost 180 degrees. One small tap. Just a huge amount of turn. Same thing sort of laterally over here. So that would be the thing to do. Also, I mean, I could just add mass to our ship, which is another thing we don't really tune right now. But let's say I made the ship 10 times heavier. Then, set mode flight. Yeah, now it doesn't twist anywhere near as quickly. I mean, it doesn't advance as quickly either. This is the same as making your engines 10 times weaker. Just make your ship 10 times heavier. But again, I'd probably want these thrusters in the back to be a lot more powerful, because this feels a little slow and sluggish. Maybe tuning down the drag, too. At this point. I still want a little bit of it, because I want it to come to a rest if you're no longer thrusting. Well, that's not bad. There we go. There we go. Up, 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 forward. Yeah, all of a sudden this feels a lot less crazy. I mean, it's still pretty crazy. Just not as much. And yeah, the camera rotation. I keep forgetting, and then I try to rotate while we're moving, and then things go bad. One of my... Might be a little hard to figure it out at this point, but most likely what's happening is one of the things in here is using global position when we really want a local position. I wonder if it's something like this. No. Oh, it's an orbit mode. It's an orbit mode over here. Yeah, remember we spent a fair amount of time here. I'd left something buggy in here because I'm like, oh yeah, something is dumb. See how this is like a to-do fix me? Yeah, we never finished this quite correctly. So that's all that has to happen. The orbit mode has to be corrected to not be dumb. Also, if I recall correctly, the way we left it as well, we have a gimbal lock that happens when we're at the top, which we probably don't want. So yeah, it's just the orbit code's got to be refixed up. But I'll leave that as an exercise to the viewer. To do, fix me, exactly. Big engine, small engines, that's true. Yeah, that's true, actually. We could just, instead of making it tunable, we could have two variants of the engines, which actually sounds like a really smart and slick solution. God, you people are good. You people are very good. So let's say we took our thruster here, we duplicate it, and renamed this to be, like, RCS. Dropped it into the world so that we can make some quick little tweaks here. Let me just move it off to the side so we can see what we're doing. Right, so if we take this object and we take the graphic and we bring it down to, say, half size, right? And there's thruster code here. One thing we don't do is we don't have the thruster strength be public, so let's make it be public. So we'll leave our main engines on a 10, but the thruster will just tweak to be at... Well, actually... Maybe I'll leave the thrusters on at a 10. So now we've got RCS in there. That's good. So this is the RCS version. We're going to apply that in my canvas bottom toolbar. We're going to add a fifth type of element. We're going to drag the RCS prefab in there. So now we've got RCS, but I'm going to take the actual thruster because I increased the weight of the object, and I think that's okay. I'm just going to make the thruster more powerful, like 25. So... that updates the existing thrusters. And then if we decide to, I'm going to get rid of this pre-created ship here now. Yeah. Let me do that. Let me go and get our original ship route back active. Let's make sure our scripts are pointing to the actual original script route, which is that. The obstacle course as well needs to point to the correct one. I don't think the camera was ever pointing to any kind of object. No, that should be okay. Now if I hit play, we've got that. I can add, let's see. Let's make our ship a little bit longer here. And then another cube like that. We're going to add a thruster on the back, and we'll add RCS here, here. Oops, clearly have to work on my offset a little bit, but that's okay. There, 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 and there. And then what do I want? I want this thruster to respond to W. So we're not even going to have a thruster on the other side to slow down. This guy is going to push us down. So I want this one on an R. I want this one on R. I want this one on F, this one on F. So then we get a twisting motion. I want, when I hit D, which goes to the right, I want this one to activate and this one to activate. And then A for the left is going to be this and this. So now if we set mode flight, twist, 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 forward. Oh yeah, this still has the lower weight. Just pause a second. We're going to make sure that the mass is standardized to around 10. And I mean, the mass should change based on how many cubes and stuff you've got. That's something we should work on in the future. But there we go, we got that. So my particle emitters don't look right because my thrusters aren't positioned correctly, or my RCS isn't positioned correctly. But it actually feels very, whoops. My perspective is off, and then I tried to rotate, and my camera is broken, so everything is poop. Excellent. But that is probably better. Let's go and tune that. So ship route over here. What I want to do is I want to drop an RCS in the scene, and then for simplicity, attach it to the ship route. With a Z of 1, or never mind, 0.5. Oh yeah, because it should be linked there. And yeah, so this is the root of this game object, and clearly the graphics are offset. So we're going to take our thrust emitter and just line it up there. There we go. So that should be okay. We probably want to tune down the particle emitter as well. Have it be less particles or fewer particles that don't last as long. Half as many particles that last half as long, so it's going to feel a lot more lightweight over there. So we're going to go and apply the changes to RCS, and then delete it from the scene, and then go and pop an RCS on there. Set mode flight. Oh, it doesn't have a bind, so let's just bind it to W or whatever here, and then there we go. And of course, you can fly your ship just with the RCS, but you might want the thrusters for a lot more power. So actually, this one should be bound to W. This one here should be bound to R. Set mode flight. Oh yeah, we're offset. Our weight is offset here, so when we push forward, we're actually tilting in a kind of an awkward way. Vroom! Wee-hee! And then if we stop, because of the drag, it will eventually bring us to a stop, which again, isn't realistic in space. Actually, I say that, I forgot that we didn't actually save those changes. We want a little bit of regular drag. I like the one angular drag. It makes life a lot simpler. Oh, and again, yeah, we'll boost the base weight of the rigid body. And it doesn't currently scale based on how many cubes, but that's easy to do. You can make it so that whenever you add a cube, the mass of the rigid body goes up by, 1 for the base object. So basically, every one of these ship parts, yeah, but by its base, it doesn't have, that's interesting. It doesn't, we don't have a normal component for all ship parts, which is good because we're trying to cut back on weight. How would we do that? Well, what we could do when we add a ship part, we could actually go and find the collider, right, on this. Any collider that's not a trigger, basically. And figure out its bounding box, so we get its volume, and then we assume an even density, and then we can tweak that, but pfft, that's all right. I think I'm kind of happy with this. I think, Yeah, all right. Let's figure out the adding mass thing, which is very easy to do. So again, there's something to be said about having, if there was everything had a component called, like, say, ship part, which didn't really do anything but had variables on it for setting mass. We could do that, but I think it's going to be perfectly fine if all we do is when we add a ship part. Right here. let's say we can, from this, GameObject.transform dot get component of type collider. Now this is only going to get a single collider on the child, which may or may not be accurate. Let's say get components colliders. So we're going to get an array of colliders. Now collider is a base type. It gets subclassed into box colliders and mesh colliders and so on, but this should be okay. So we do something like this. To calc mass, get a list of all the colliders in the new part. So then we can say something like, for each collider call in calls, we can get the bounds. Now this is not going to be an exact calculation of the volume, but it's going to be pretty darn close. I don't think it has just an easy volume type whatever. We'd have size is basically it. Total size of the box, yeah. So the size, so the volume, float volume, is simply equal to bound size dot x multiplied by the size in y multiplies by the size in x and z, right? Length, width, depth. God damn, this is like way too like long time ago geometry here. But yeah, that's the volume of the box. And if we assume that we have a density of, say, 1 per unity unit, then what we're really looking to do here is, so float mass equals 0, mass is equal to, or gets added volume. So assume a density of 1 per unit. So our little 1 by 1 by 1 cube, we just add 1 unit of mass over here. And then what we'd want to do is find the rigid body. So for this, what we want to do is so the collider, this is the thing we clicked on when we're adding the object. So we know that if we actually go the collider, is collider hit info? No, it's not. Right, but that is the correct, right, it is just the actual collider that we clicked on. So what we need to do at this point is we have to say, listen, this collider's dot transform, we want to get a component in parent. We want to go up the hierarchy and find the rigid body. Okay? This is the only rigid body we will find going up the stream from the collider that we clicked on in edit mode is going to be the rigid body that's attached to the actual spaceship. So we're going to change this object's mass based on this mass that we just calculated from looking at all the colliders in the newly added object. As such, oh, whoops, where'd that come in from? As such, if our ship root starts with a mass of, let's say 1, let's say it always has a density of 1 per cubic unit in Unity. If I hit play, and we look at the ship root, it's got a mass of 1. If I add a cube on here, our mass doesn't change. Why isn't our mass changing? Number of colliders, new object, 0. Well, that's not what we're looking for. Why is the number of colliders in the new object 0? That's not true. It's got a box collider. Oh! Get component in children. Get components in children. I'm using the wrong call here. That's my fault. Get components in children is what I'm looking for. Okay, let's try that again. Hit play. Select the ship route. We're going to look at the mass. I'm going to click cube. I'm going to add a cube. Mass 2.04. Oh, which makes sense. Okay, ish. It's calculating in the mass of the little knobbly bits over here. Which it really shouldn't, because these knobbly bits aren't supposed to be part of our actual physics. We could filter that out relatively easily. So, basically the same sort of thing over here. Mask for this collider is call.gameObject.layer, and then we say if that. So we're doing the inverse here. Here we were confirming, here we were confirming that whatever we clicked on was part of the snap point layer mask. Here we want to confirm that it's not part of the snap point layer mask. So we need this new colliders mask with the Boolean and over here should be equal to 0. This call is not a snap point, so calc its mass contribution, like that. Da 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 da. I mean, it would hardly make much of a difference, but it would be wrong and therefore annoy me. So mass is 1, add a cube, it should go to a mass of 2. Oops. No. Why 4? Oh! Shh. I copy and paste error. The most common error probably in the game is a copy, or in programming, is a copy and paste error, where you copy something and then forget to change something. Let's try that one. This time for sure. 100%. Probably. Adding a cube. Mass goes to 2. Let's add a rectangle. This should add 2, so our mass should go to 4. And it does. 4 and a tiny bit, and a floating point rounding error. That's fine. How much mass does a thruster add? No, there we go. And so again, we're assuming an even density no matter what. We're not caring about material or if something is hollow or whatever, which isn't necessarily realistic, but it is there. We could do some sort of override thing. What we could do is we could have a component that is optional, right? And what it is, it's like a mass override or a density override component. So we would check to see to do question mark. We could check if there's a mass override component on this new or density override on this new object, and therefore not assume a density of 1, on a case by case basis. Very easy to do, right? So that way, some things could be heavier, some things could be lighter. We could have a mass override that would that could have a density of 0. So therefore, even though this object has, a hitbox and all these things, it's, we don't count its mass, or, basically nothing. So you can do all kinds of stuff like that. So there's another to-do for you guys to consider with. We're going for an hour and 20 minutes. I think this is going to wrap us up. Oh, you got a question. Someone was asking what this does. and also presumably as a follow-up this. I do actually have a standalone tutorial specifically made to address what we were doing here in this project that explains bitwise operators. So, in fact, I have a ginormous comment over here explaining what this does. This is a left shift operator. This, okay, so the number 1 in binary is represented thusly, right? This is the number 1 in binary. It's a bunch of zeros followed by a 1 enabled, right? In binary, you only have zeros and ones. So this is a 1 in binary. This is left shifting at 8 spots. So we take this one and we literally just move it over to the left. This also works if you have a more complicated number. So let's say you had something that was, whoops, you know, some sort of more complicated binary number. Apparently I keep putting in minuses over here. And let's say we're shifting this. If we're shifting this over, say, by 2, then what you end up with is something like this. We'll just remove the first 2 and then fill in these 2 slots with zeros, right? So there you go. That's all it does. It takes your binary number and shoves it over to the side. It can be handy for a few things. Technically, every time you shift something over to the left by 1, you're actually multiplying the whole number by 2. And actually, for every 1 that you shift things over to the left, you are it's like exponential 2. Let's say you were trying to calculate something that's a power of power of 2 multiplied by something. Right? So if you're multiplying something by 2, 4, 8, 16, anything like that, you can do it extraordinarily quickly by just shifting over something by 1, 2, 3. Like if you're left shifting something by 3, what you're doing is you're multiplying that whole number by 8 extremely quickly. It works the other way for division as well. So sometimes use it for that, for some really fast math when you're working with sort of powers of 2 kind of stuff. But also it's very common to use it for bit masks, which is what we're doing over here. And that's all explained in this giant comment, which you can either review my my videos for it, or you can download the project and then read the comments. Any other questions? Yeah, computers can bit shift incredibly fast. Absolutely. All the bitwise operations are incredibly quick. This sort of comparison here and things like that, mega quick. I thought if you have 1100 and you shift 2 to the left, it becomes 0011. I don't think, when you shift to the left, I don't think it wraps around. I'm pretty sure it doesn't. Like, if you have, I may be wrong. This is something, you know, probably someone else can confirm. But I think normally, if you had something like this, and you shifted it over by 1 slot, I believe, and I could be completely wrong in this, I believe you end up with this. But you can test it. I might be completely wrong. Maybe you do end up with something like this. Or, you know, I mean, obviously you need 32 or 64 bits or whatever to fill that in. But I think it falls off the end. Or does it? Oh, does triple 1 wrap? I don't know. This is actually literally something you know how you can solve this in about 3 seconds? Google it. Bitwise operator wrap. Or, you know, the triple 1. Right? Like, is there a bitwise operator with triple left? There might be. It might depend on the language. So in Java, no, in Java there isn't one. Some do, some don't have the triple operator. So, like, apparently this, which I've never heard of personally, but apparently that one will do the, Java adds one this way, interestingly enough. But not one that goes the other way? I'm just reading Wikipedia here. And do they do different things? Listen, you guys can just read up on yourself. There's an amazing thing called the internet, an amazing tool called Google, and when you have a straightforward question like that, you can just look it up, and it's awesome. So, this is not the right form. Shifting without sign extension. Oh, if you want to wrap, you use unchecked scope. Oh, interesting. But yeah, I don't have a simple answer for you on those particular operators, because mostly I do shifting stuff for flags, and those sort of questions don't come up, and you know the triple sort of shifting doesn't come up. Like, it's basically technically these bit masks should really all be unsigned ints, because you don't use the sign part of it, but my flags never end up being that big for it to matter one way or another. So there we have it. Any other questions? but you are the internet. And I mean, don't get me wrong, like, I'm very happy to do tutorials to answer, certain questions and things like that, but usually something that can be answered with a simple yes or no. It's like, well, there's not really much of a point in making, if you can Google it and it's a yes or no answer, not much point in making a video for it normally. But sometimes I'm surprised about what gets a lot of questions and what doesn't get a lot of questions. There's some things I'm like, how are people not asking for a tutorial for thing? Because holy crap, it seems like a really complicated topic, but maybe it's just complicated to me. All right, well, I don't see any questions come in at this point, so we're going to go ahead and wrap this up. We went for an hour and a half. A little bit longer than expected. Well, a little longer than I claimed the stream would be. I said it would take an hour, but I always know it goes over a little bit, so we've got that. Those of you, the next live stream is going to be Wednesday a week from now, I think. Yeah, because I leave tomorrow for Sweden, so there's no stream on Wednesday. Saturday, I'm going to be coming back from Sweden, so no stream on Saturday. Sunday morning, both myself and A Kiss for Luck will have just returned from our trip, so there's almost certainly not going to be a Sunday Morning Heroes this Sunday. So I think the next live stream is going to be next Wednesday, so a week from now, and we'll be returning with Civilization 6. But then that weekend will be Let 'Em Dare. So once again, we'll be doing some crazy programming. It'll be a 48-hour programming live stream. God, I hope I have the energy for that. I should probably rest all next week in preparation for it, which means I don't know if there's going to be fewer videos on the main channel or what. I don't know. If you did miss any of the today's stream, don't worry. It'll be up on the YubTubs relatively soon. The triple left bracket or right bracket is called a bit rotate, which doesn't exist in C#. Cool. Yeah, and I was going to say, I don't think it's pretty standard. I don't think it's not something I've had a lot of experience with, so it must not be present in all languages. But it sort of makes sense, like you might want bit rotation, because why not? It's not hard to implement, so. On the bit shifting, it seems you're right. It discards the ones. Yeah, I was pretty sure about that. I was pretty sure it discarded that, but there is a rotation one. But most of the time, you just throw it away. You could always recover it. It's very easy for you to check to see if there's something, then, recover it. But it's nice if there's an operator added in. But apparently C# doesn't have it. So, good info. Thank you very much for all that. And I'll see you guys, I'll see some of you guys in a couple of days in Stockholm. And the rest of you, I'll see you next week. Thanks for coming out, folks. Bye-bye. Thank you, October patrons. Those are the people who pledged in October and who are supporting these videos from November through to early December, and especially these Mic Check supporters. We've got Yukofin, Adam Conway, Drazian, Jan Torivel, Adjective, Michael McClintock, Aaron Toyson, Craig Mortel, Stephen Wendell, Julien Auger-Lafont, Marius Fielvold, Speedy Savant, Valiant Cake Fiend, Wes Oldenboiving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you very, very much.